All right, guys, we're back here, and I am hoping you have either opened or going to open the worksheets that are in your Google Classroom. These are designed to tell you about the parts of the nose, how the nose smells, and how the nose also protects us from airborne pathogens and dirt. So go ahead and look at the first worksheet, which is a diagram of the nose and the interior parts of the nose, and label the parts from your own knowledge or by using some online sources, and also do the matching underneath of that, which tells you what those different body parts do. Let me pause the video here and let you work on that. I'll come back in a minute or two after your teacher's ready and tell you what those answers are. Okay, I hope you had time to fill in those 5 body parts in the nose. From top to bottom, if I'm remembering correctly, would be the olfactory bulb, then the nasal bone, then the nasal cartilage, which is here at the end of your nose, then the olfactory receptors, which are the long, thin nerve endings, and finally the nasal cavity, also sometimes called the sinus cavity. So what are these parts doing? If you match them up correctly, the olfactory bulb is processing information from the receptors. The receptors are receiving that information, and this is where the molecules of a scent are going to be trapped and set off an electrical signal in the nerves themselves, which, as I said, gets processed in the olfactory bulb to some extent. The olfactory bulb actually is very important here. It actually decides which signals are going to be sent on to the brain, which are not, and it also helps to integrate some of that information before it's sent up to the brain. The nerve receptors, which are more or less below the olfactory bulb, they are there to actually trap those molecules, and they are very specific. Okay, as the handout says, there's more than 6 million of them, and this is a genetically predetermined number, so different people have different levels of them, and many animals have many more than humans do. But basically, each of these receptors is designed or built in such a way that it can only trap the one sort of molecule that's coming through the air. So these are roughly about 400 different types of them. When we smell something, like say you smell a baking pizza, all right, you're getting a mixture of molecules there from the tomato sauce, from the cheese, from the crust, as it changes from raw to cooked. You're getting some smell from vegetables or meat that might be on there. So all this is mixed together, taken in to these many millions of receptors, and then they are combined in the olfactory bulb, and then the combination signal is sent on through the olfactory nerve to the brain, where the brain decides that's the smell of a pizza. And pizza clearly doesn't have just one smell. It's a combination of molecules that mean pizza. It's like spelling letters of a word. You write a word like apple, and it's composed of 4 letters, A and P and L and E. But because there's 2 P's and it's in a certain order, we know that means apple. All right. If you took the APPLE and recombine them some other way, you might come up with PEAL. And PEAL means the ringing sound of a bell. All right, a peal, a bell peals like that. So the order that the signals are received, the exact type of signals that are received, this is what the brain and the olfactory bulb are working with to determine pizza smells like that. All right. Now, going on down the list, there's also the nasal cartilage, the soft bone here, so to speak. It's soft because, well, it gets impacted sometimes, all right? We get hit in the face sometimes by things, and it's been adapted to be soft and not break easily. Of course, if you're hit in the face very, very hard, the nasal bone, which is up in here, will break, and that can be quite dangerous, actually. The bone can actually go up and go into the brain. The brain is very close to this part of your head. But the cartilage is there as kind of a cushion to help prevent that kind of breakage, and it can be pushed around quite a bit, as we all know. Finally, there's the nasal cavity or sinus. This is the space where the olfactory receptors are situated. The nasal cavity is created with folds of cartilage behind the eyes, behind the nose, and this improves the airflow to make sure as much air as possible reaches those receptors to really improve your sense of smell. More molecules will hit the receptors, more molecules will be received, and this increases the chance you're going to actually smell something important. Okay, so that's a run through of the 5 parts on the handout. Let's pause this again, and when I come back, I hope you will have done the questions on the second part of the worksheet, and we'll talk about what those answers are. All right. Right, so let's move on to the second page of the handout, which is about the multiple choice questions and a couple of short written questions. These are concerning the function of those parts. And if you've been listening to my previous talk, hopefully these aren't too difficult. The first question asks, what's the purpose of the mucous membrane and the nose hairs? Now, they're related purpose, but they're kind of different in how they do this, all right? I think most of you probably figured out that these are defensive. Their job is to prevent certain particles from the air of getting deeper into our respiratory system where they could really cause us some harm. By being trapped in the nose, they can be removed from the body pretty much harmlessly and not get into the really delicate tissue of the lungs where they may end up permanently trapped and interfering with our ability to breathe, all right? Certainly, we think about respiratory diseases, infections, really, that would be able to get into the lungs. The protection at the lung level itself is very weak because there's so many defenses above that that are supposed to be working. So the first of those defenses really is the nose hairs and the mucous membranes. So the nose hair's job is to slow down the airflow. A lot of people think they physically trap things, and they do a little bit, but that's mainly because they are generally covered with a little bit of sticky mucus, all right? Mainly the nose hairs are there to slow the airflow down and give the airflow time to interact with the mucus and also actually interact with the chemoreceptors, the olfactory receptors, which are there to do smell, all right? So the nose hair's job is that. The mucous membrane and the mucus that it makes is there to actually trap particles from the air, and they do a pretty good job of this. There's actually mucous membrane all the way down our respiratory system through the trachea, which is our breathing tube in the throat, into the bronchi and bronchioles in the lungs. This is all lined by different kinds of mucous membrane, which trap these particles before they reach the really thin, vulnerable tissues down in the deeper part of the lungs. The mucus sticks to particles, and there are a series of cells along the mucous membrane that actually push that mucus out into the throat where you end up swallowing it, or down to the front part of the nose where it can be blown out. When we swallow, all right, or when we blow our nose, we're removing mucus with those particles in it. Pathogens, bacteria, viruses, this kind of thing would also be removed in the same way. So that's the body's defense mechanism.